Calculus. This is a video overview of the notes for lesson 2.5. I'm just going to go over the steps with you in case you weren't sure of what we did with implicit differentiation. So at the top, we talk about explicit form of an equation versus implicit form. And all the way through lesson 2.4, you've been able to solve equations in the explicit form, which means the equations were solved for y. So you only saw y on one side of the equation. For implicit form, the equations have x and y in them, or at least two different variables, and it would be difficult to solve the equation for y. So in order to find the derivative of such an equation, you have to do what we call implicit differentiation. So the method is right there. We're going to differentiate both sides with respect to x. That means when we differentiate x, it's just normal. That's what we've always done before. But anytime you differentiate a y, you're going to back it up with dy over dx, or the notation y prime. We're going to collect all the dy over dx's on one side. We factor them out, and then we solve. So for example 1, we started off with the derivative of y to the third, and that's 3y squared. Because it's the derivative of y with respect to x, we back it up with dy over dx. Then we moved on and did the derivative of y squared, and that's 2y. And because it's a y, we back it up with dy over dx. And then we did the derivative of negative 5y, which is just negative 5. But because there's a y, it's followed up with dy dx. And then we did the derivative of negative x squared, and that's negative 2x. And the derivative of negative 4 was 0. From there, I'm showing with the arrow that we take the 2x to the right side, and therefore you have sorted all your terms. So you kept everything on the left that has dy over dx in it. Then I factored out the dy over dx from the left, and then I divided. So right here's my division step. I divided to cancel those out, and I'm left with this derivative 2x over 3y squared plus 2y minus 5. And then I showed the class if I had a problem where it said to find the equation of the tangent line, I would plug in my ordered pair directly into my derivative to get the slope. So I'm plugging in 1 for x and negative 2 for y, and getting 2/3 for my slope. That's right here. And then I'm writing the equation of the line. Okay, so on example 2, we're just using the other notation for the derivative of y with respect to x. We're just using y prime. I highlighted the fact that x squared y has to use the product rule. So we started off by taking the first times the derivative of the second. So we did x squared times the derivative of 1y, which is 1, and then we back it up with dy dx, or y prime. And then to finish the product rule, we did y, so then we're here. We did y times the derivative of x squared. So y times the derivative of x squared. Then in orange, I did the derivative of y squared. So that's this right here. And so that's 2y and then y prime again because I did the derivative of y. I'm going to throw this term here to the other side because it doesn't have y prime, and that keeps the other two terms together that have y prime. I factor out y prime and then divide, and I have my answer. So this one here, let me shrink the work down so we can see everything. Actually, we'll go a little bit bigger. Your 6th hour class decided that they would take this original function up here and they would go ahead and FOIL that out first. They thought that was an easier way to go as far as finding the derivative. So I have that work in purple. And then I highlighted to the kids that this is the product rule, and so is that right there. And so I have first the derivative of 3x to the fourth, that's 12x to the third. Then notice I left my 6 on the outside. I then took x squared times the derivative of y squared. That I'm going to underline for you here in blue. So that's x squared times the derivative of y squared, which is 2y, but because it's y, I back it up with dy dx, plus the second times the derivative of the first. So y squared times x, the derivative of x squared. So that's the other piece of that product rule. It's the y squared times the derivative of x squared. And then I have the derivative of 3y to the fourth, which is 12y to the third. But because it's y, I back it up again with this dy over dx. And then I did the same thing on the other side. I left my 100 on the outside, and I did the product rule again. So it's x times the derivative of y, that's right here, plus y times the derivative of x right there. From here, it's just a bunch of simplification steps. So I multiplied my 6 all the way through and basically just kind of cleaned everything up. On the right, I multiplied by 100. Then I did a lot of sorting. So if the term had dy over dx, which is this one and this one and this one, I collected them on the same side. Everybody else got kicked off to the right-hand side. Then I factored dy over dx out, and then I divided. Now, it says that we're going to find the slope only of the tangent line at 3, 1. So once I was to this point, I plugged in the ordered pair 3, 1 for x and for y, and worked it out till I got 13 over 9. These are the practice problems here. I'll show you how to do number 10 right now in these notes. And so here we go. I'll walk you through the whole step. They're asking you here for a second derivative. And by the way, if you missed class on Tuesday, November the 11th, we did this one in class on Tuesday. Okay. I'll also show you the warm-up we did today to help you understand what we're doing again. All right, first derivative. So I start with y squared equals x to the third. And the first derivative is going to be 2y dy dx, because I'm, again, differentiating with respect to x, equals 3x squared. And then I would have dy over dx equals 3x squared over 2y. So that's our first derivative. No big deal. Our second derivative is d squared y over dx squared. That's just the notation for a second derivative. I'm going to use the quotient rule on 3x squared over 2y. So I'm going to take the bottom times the derivative of the top minus the top times the derivative of the bottom, which is 2, but it's from 2y, so I need dy over dx over the bottom squared. And I don't need parentheses there, so let me change that. I'm going to clean that up a little bit. Okay, I'm going to make a substitution. Now, I know that dy over dx is this right here from my first derivative. So I'm going to take that and put it in right here. And then I'm just going to clean it up. So I'm still cleaning things up. And then I'm going to get a common denominator. And remember, you can take that up to the top. So that's how I'm getting that 4y to the third. Okay. Now the idea is to get this as cleaned up as possible. So up here at the very beginning, we said that y squared is x to the third. So what I'm going to do is I'm going to take out that y squared and a y squared from in here and put in x to the third. So I'll have 12x, x to the third, minus 9x to the fourth, over 4. Y to the third is y and y squared, but y squared is x to the third. And then I'll have 12x to the fourth, minus 9x to the fourth, and then clean it up one more step. And I will have my second derivative. So there's number 10 in your practice problems. It's a little bit long, but it's doable. It's just a lot of steps. So we did that one together on the board today. The warm-up problem that we did today was this one. It was a lot simpler. So I'll just share that one with you today as well. And then I'll end my video. So today we did this one for a warm-up. And so we start off here with this right here, and that's the product rule again. So x squared times the derivative of y to the third, so 3y squared, back it up with dy dx, plus y to the third times the derivative of x squared. So it's the first times the derivative of the second plus the second times the derivative of the first. The derivative of minus 5y is minus 5, but I back it up with dy dx, and then 32x, and then equals 0. And then I have, let's see, I'm going to kind of sort things and move things around and clean things up kind of all at the same time. That would be a negative when I bring it over. Okay, so then I factored out my dy dx. The last step is to divide by what's with dy dx to give me a final answer here. Of that right there. I shared with the other hours that if this were an AP problem, they might very well factor out a negative from the numerator and put that on the denominator, switching the order of their multiplication. So these answers are equivalent. I'm okay though if you get to this point. Okay, so if you missed class on Tuesday, November the 11th, we just basically had a work day. We did the warm-up, we did number 10 from your practice problems, and we had a work day to kind of work on this lesson. tomorrow is the Veterans Day Assembly here at school. So second hour calculus will not happen. And sixth hour calculus, I think we'll play like a game of Kahoot or something just to reinforce some of the ideas that we've been covering in class. And then on Thursday, we'll start lesson 2-6. Hope that gets you up to date. Talk to you guys soon. Bye.